Let's talk more about cosets. So we have a group and a subgroup, and A and B are two elements of G, and we're going to talk about coset equivalence. That two cosets are the same if and only if, when I multiply H, A B inverse, I get back H. Look at how this goes. For example, here I might have H could be the identity in 1, 2, and I can look at the different cosets. So notice I get 3 different cosets according to the colors, and then what we can do is we can notice, well, when are they the same? So 1, 2 E inverse is equal to E 1, 2 inverse. All these things are equal to 1, 2. So I'm picking out my A's and my B's. So here my A is equal to 1, 2, and my B is equal to E. And vice versa. Here my A is equal to E, my B is equal to 1, 2. My A could be that, my B could be that, A, B, A, B, A, B. In all these cases I get 1, 2. And 1, 2 is in the original subgroup, maybe right there. So that's what we're saying. We're in the if you have this equation being true, then it's going to work out that these two cosets are going to be the same. So let's suppose that we have this. So we'll prove one direction first. We can. What a coset means. So HAB inverse is equal to, you have all the set of H's times AB inverse. So I'm just going to multiply this AB inverse through, but in particular I'm going to multiply it by that. So I'm going to get AB, E times AB inverse times a whole bunch of other stuff. So I'm going to get AB inverse times a whole bunch of other stuff. So that's why AB inverse equals H implies that AB inverse is going to be in H. Because if I have H equal to HAB inverse, AB inverse is pretty clearly, it's always going to be in here. And then if H is equal to that, then I get AB inverse. All right, so HA equals HB, you can think of it as just, I can multiply both sides by B, and I get that HA equals HB. Great. Now suppose we have, well, AB inverse is going to be an H. Again, A is going to belong to HB. That means that A is equal to HB for some H, and then that means that AB inverse equals H, which belongs to H. So H, I can multiply by AB inverse on both sides. But this thing is in H, because AB inverse is in H, so its inverse is in H, so that belongs, so this is one big element of H. We call it H star times AB inverse, and that's going to be an element of this. So I get containment. So if you pick any element of H, I can rewrite it as in terms of the coset. So I get that containment. A typical element looks like this for some H belonging to little h, and now I'm going to show that that is in H. And that is equal to, which belongs to H, because I know that AB inverse is in H, so I can use a closure. Therefore I get the other, which gives me, so we conclude that we get equality. Thanks.